What's up, everyone? Welcome back to the channel. Thank you for being here with me today. Today I just wanted to do something different, which is why I have the camera on, which I usually don't like to do. Believe it or not, I prefer to be faceless, but we're gonna do something a little bit different today. I'm gonna write a Rust program. Now, I've been learning Rust for the past, I say, a few months, and even though I have a pretty strong background, relatively, for someone with my experience, I have a pretty relatively strong background in C because I spent the last few years just getting really deep into C, and I consider that my fundamental base language. I wrote a few relatively, I keep using the word relative because I don't want to be cocky or anything because I know I'm still, a beginner, I'm still learning, but I wrote a few relatively complex C projects like a compiler, aka an interpreter, right? That's from Crafting Interpreters by Robert Nystrom. I read the book 4 times back to back. I built a Node Nexus WebSocket database. I built a Bitcoin hot wallet, which is, in my opinion, my favorite project so far, just because I love Bitcoin, I love blockchain, I love cryptographic, everything that's involved with it. So even though I have a pretty solid foundation in C, for someone with my experience, I found that Rust still has a pretty steep learning curve. But I've got a lot better at it, and I'm progressing every day, and I'm very proud of myself for doing that. But so today I wanted to build this project, this multi-threaded web server in Rust. And as you can see, it's actually the final project in the Rust programming language book. The book that's basically the Bible for Rust. It's really good. I read it. And it's phenomenal, right? So I'm gonna build this project, except I'm gonna do it basically blind, right? I'm gonna do my best to just build it all out, all in one shot. I'm only gonna use the compiler to help me, and of course, I'm gonna look up like references here and there, maybe if I need to. But I'm gonna try my best to be as independent and as I possibly can be, right, with this type of project. Shout out to Let's Get Rusty. He made a video doing exactly this, and I thought it was super cool. Even though it was very complicated at first, and I just couldn't wrap my head around it. I had to watch it a few times, and then I read the chapter, and I built it myself. And now I just want to like redo it, just from scratch, and let's see how we go. Okay, so let's just get right into it, guys. I'm gonna go ahead and minimize this. We don't need this for now. Let's go to VS Code. Oh, by the way, I also spent the last few years just writing all my code in Vim, and I definitely see the appeal of Vim. But man, I gotta say, it's nice to go back to VS Code and have things, kind of help you out a little bit, because with Vim it's almost like you're writing on a whiteboard. There's no help, there's no assistance, there's nothing. So it's nice. It's nice to get back to this, at least for now. I might go back to Vim though. But let's start a new project. I'll go new. Let's call it Rust Web App. Yeah, let's do that. Okay. Okay. So now we're gonna go ahead and folder project Rust Web App. There might not be a lot of talking in this video. I'm just gonna go ahead and code. I will try my best to explain, what I'm doing as I'm typing, but I can't promise that I'll be, very talkative this entire video. Okay, so now that we have that, let's look at the mains. Boom, cool. Okay, so first of all, let's go ahead and build out the front end of this project, which is an HTTP server, right? We're gonna be listening for any TCP stream that comes in, any incoming connection, and as soon as we get one, we're gonna loop over it, and we're gonna send back a response. So let's start with, well, let's go ahead and start by opening up a terminal. Let's make sure that this project is running. The mic, the wire's in the way. All right, let's go. Let's go here. Let's see. Let's do let listener equal TCP listener, right? Okay. To bind that to host It's gonna return a result. We gotta unwrap that. Okay. Let's make a const localhost str 127.0.0.1. Let's do 7878 since that's Rust in a telephone book language. Basically, because 7878 is when you press 7878, it spell out Rust. Okay, so then now we have a listener that's gonna listen on localhost 7878 port. We're gonna unwrap that. All right. So now let's see. Let's see for stream and listener. Right. We don't need this anymore. What's the problem here? Not an iterator. Oh yeah. So we gotta go incoming. That's how we get the iterator. For stream and that, it's going to be a result, so we need to unwrap that again. Okay. We're going to make a different function just to handle this. So we're going to say handle connection stream. So in the book, it basically taught us to do this type of coding, which is it's called it's kind of like test-driven development, except this is called compiler-driven development. So we're just gonna follow the compiler, and we're just gonna do the bare minimum, and as long as the compiler keep accepting it, we're just gonna keep iterating on that, and we're gonna keep expanding on that. And as you can see, well, you'll see what I'm doing in a minute. So for stream, we're gonna do a handle connection. We're gonna pass in the stream. The stream is most likely gonna have to be mutable, but let's see. Connection. Okay, so stream is going to be a TCP stream, right? Okay. Boom. All right. So when we get into the stream, we're going to read from that stream to see what the request is going to be. So we need a buffer, first of all. The buffer is going to be a U8, which is a byte, a single byte. It's going to be 1024 in length, and that's going to be, let's do 0. We're going to 0 it out. All right. Did I do that right? File integer. What's the separator? Oh. Mismatch type, found integer. Let's see. I forgot how to do the initialize a buffer. Okay, we'll get there. Okay, so we're gonna do stream.read, right? We need a buffer. We're gonna pass in that buffer. So this is the problem here. Expected. Oh, wait. U8. Okay. Does that work? Expected muted. Okay. How about that? A mutable borrow. Yes. Go ahead. Okay. String cannot mutate immutable variable. Yep. Muted stream. All right. Let's see. What is the problem here? Unwrap. We don't need an unwrap. Okay, so we would have to redefine the stream to be stream.unwrap. Okay, that's better, I think. For stream, does not need to be mutable. Stream. Let's see, use run. Okay, well. Self. Read. Huh. Okay. Alright, anyways. So now we're gonna go ahead and get make a variable called get. That's gonna be a string. I mean it's gonna start out as a string literal, a constant a string slice, right? but we're going to convert it into bytes so that we can compare it with the HTTP request from the client. We're going to see what they want to request, whether it's a get, a post, and then we're going to send back the appropriate response. So for now, it's going to be, what is the what's the reference for that? Let's see. It's going to be get, I believe, like this TP 1.1, if I'm not mistaken. All right, I got to see the reference for this. HTTP request example. Yeah. Yep. Get, and then the address, and then HTTP 1.1. Okay, cool. So that's going to be get. We're going to turn that into byte. So that's going to be a U8, an array of U8, and then we're going to do one also for sleep, the same way, except it's going to have a sleep URI, HTTP slash 1.1 dot s bytes. Here we go. All right. Okay, and then we're going to go here. Let's see. We're going to compare that. Buffer if buffer dot starts with get. Then we're going to do something else if it starts with sleep. Then we're going to do something else, or else we have something else entirely. Okay, so then now we have the comparison. We're going to compare the HTTP request with each one of our handler here, and we're gonna respond appropriately. So we're gonna create a tuple. It's gonna be status and file name. Depending on what this expression returns, we're gonna return a tuple of according value. So screw that over. Let's see, if it's get, then it's going to be, what is it, HTTP 1.1, I think it's 200, okay, if I'm not mistaken. Gotta make this a tuple. Return an index.html. Alright, let me see. What is the HTTP response example for 200 is HTTP. Yep. Okay. So we're good on that. All right. And then if we have a sleep request, it's going to be the same thing, except we're going to want to let the server, we're going to force the thread to sleep for 5 seconds. So it's going to be duration from seconds 5. Okay. We're going to go thread sleep. Is it thread sleep? What was it? What was it? What was the sleep? STD thread sleep. There it is. Okay. STD thread sleep. Does that look right? Sleep. Yeah, sleep for 5 seconds, and then we're gonna go ahead and process the request here. Otherwise, it's gonna be HTTP slash 1.1 404 not found, and it's gonna be a 404.html. Okay. Does that look right? It looks right. If else have incompatible types. Why? The buffer starts with, it takes in a U8, so that's right. Else, we're going to return that as a tuple. Huh. Start with file name string. All right, let's keep going. We're going to need to let's see. HTML, index.html. Rust. We're gonna make a dummy page, dummy HTML page. It's gonna be Rust is dope. Nice. And then we're gonna do another one called 404.html. Same thing. H1 404 not found. Okay. Alright, now that we have that, we can use that to be sent back as a response. So, okay, let response equal format. We're gonna do, let's see, the status, rn, content, length, alright, rn, and then the body. Okay. Response status, content.link, and then content. Obviously, I don't have a content variable yet, but that's what we're going to do right now. Let content equal fs from string, wasn't it? Read to string, yes. It's going to be file name, fs, okay, go ahead and import fs, read to string. I have to unwrap that because it returns a result. Okay, so now we have a content response. Okay, that looks okay, right? Content length, the body. Do I need that? Let's try that. Okay, what is the problem here? If and else have incompatible types expected, consider removing this semicolon. Where? Right here? Oh yeah, definitely. Okay, so then now we have the handle connection. We're gonna we create a buffer. We're gonna read it from the stream, the request into the buffer. We compare that buffer with our get and our sleep request, and whichever one it matches, we're gonna return a tuple of status and a file name, and then we're gonna use that status to create a response, as well as that file name. We're gonna convert it to a string from the HTML file that we created into content, and then we're gonna follow the HTTP protocol, and this is gonna be the header, and this is gonna be the body right here. Okay, so then now we gotta send back that response. Let's see, stream dot write all, right? We're gonna write the response, but I think it has to be in bytes, right? Yeah, it has to be bytes. So we're gonna have to convert all of this into bytes as well. It's gonna be as bytes. Does that work? Format. What is wrong here? Content. Wait. Oh no. Not mean to do that. Hold on. Response equal format and content length. Okay, that looks right. Boom. Content.len. Mutable buff. Response. What is going on here? This is the format. Okay, temporary value drop while borrow. Consider using let. Binding to, I did do that. Response. about we do that instead? Does that work? Okay, I think that's better. What is this? Unused result. Write all. Oh, okay. And then we gotta unwrap this because it also returns a result if it fails. Okay, and then we're gonna flush it. And I think that's it for the handle connection. What is this? Unused result. Oh, okay. We gotta unwrap this too. Okay. I think that's it. We can try it now to see if it works so far, right? Less than 9. Okay. Let's go ahead and give this a try. Unwrap handle connection. Okay. Let's do cargo run. It's gonna take a while to compile. Oh, it's already running. So, hold on. I don't like that. Let's do a print line real quick. Listening on localhost. Listening on localhost, and then for stream. All right, so boom, boom. Okay. Okay. All right, let's do that again. Okay, so now it's listening on localhost 7878. We're gonna try that. We're gonna try 2 different ones. One's gonna be just 7878, and one's gonna be 7878/sleep. So, first of all, if you go to 7878, okay, so now you see that it works. The HTML is being returned properly, and the server has sent back an appropriate response. Now, in order to demonstrate the inefficiency of the blocking mechanism of the stream, the way that we wrote the code so far, which is just looping over the entire stream, I mean each of the stream, and then processing each one by one. I'm going to show you why that's not a good idea. So if we do one with sleep, which is automatically going to stop for 5 seconds, and then we're going to do another request right away, just a regular request, you're going to see that this request will not be processed until the sleep request is processed. So this request is going to have to wait 5 seconds in line, even though it's just because of this request right here. And you're going to see that right now. So I'm going to go ahead and press enter on sleep, and then enter on this one. As you can see, they're both loading, and they're both going to finish at the same time, even though this it should be way more efficient, meaning this should be handled first, and then this should be handled. So with that, we can now, the program is working, so we're gonna go ahead and make it better by using multi-threaded server. All right, so let's go ahead and exit the server. Exit these two. Okay. All right, so we could just simply do a thread spawn and create a new thread for every single connection that comes in. But by doing that, we're exposing ourselves, our server, to a DOS attack, which is, if someone just repeatedly just keeps sending in request after request after request, it's gonna overload our server, and it's gonna shut down. So it's very inefficient, and the overhead for creating a thread every single time for every single connection is just extremely inefficient, and that's just not a good way to do things. So we're gonna do this different method. This is the method that was taught in the book. So what I'm gonna do is, instead of doing thread spawn like I usually would, I'm gonna use a different way I'm gonna create a variable called thread pool, right? And the thread pool is gonna consist of 4 different threads, and it's just gonna sit there and it's gonna wait. And then we're gonna have workers basically always listening, always waiting for a connection. And as soon as a connection comes in, that worker is going to come in, pick up that connection, and then it's gonna go to one of the 4 threads that's already been assigned, and it's gonna run the program, run the handle connection function closure, so to speak, right? So you see what you see what I mean right now as I write down the code. So now let's go ahead and let's keep going. We're gonna do let pool equal. We're gonna create a new thread pool, so it's gonna be thread pool new 4. So we're gonna create 4 new threads in the thread pool, right? And then inside of that pool, instead of handling the connection on one thread, we're gonna do pool.execute, and it's gonna take in a closure. So that's gonna be a closure like this, and take the handle connection stream and put it in there, just like that. So now obviously this code is not working because the compiler doesn't know what a thread pool is. We have to build that. So we're gonna do it step by step. Let's see. I'm gonna go ahead and create a new file called library lib.rs, and let's see, I'm gonna put the main inside of a binary folder. Okay, just like that. So now it becomes a library crate. So in order to implement the thread pool, let's go ahead and do the bare minimum, the MVP, most viable product. So public struct thread pool. Okay. Okay, we need to import that. So it's gonna be use Rust web app thread pool. Okay, so now the error is gone, but now it doesn't know what new is. It doesn't have an associated function called new. This is an associated function and not a method because we're not taking in self. We're not taking in the instance of that particular object. So we're going to create that associated function right now called new. Let's do implement thread pool. Okay, pub function new. Right, it's going to take in a usize called size, and return a thread pool. Okay, just like that. Let's see if that satisfies the compiler. Yes, that does satisfy that. Even though it doesn't do anything, even though the functionality is not correct, at least it satisfied the compiler, so that's good. We'll just keep going. So execute. We need to also create. This is going to be a method because it's going to take in a self. Mute self, right? And then we're going to take in a closure. So let's see, how would I do this? So we're going to go ahead and declare a generic called F, right? We're going to take in a closure called F with the trait bound of F, where F is going to be fn once because it's a closure that's only used once, plus send because it needs to be sent across threads, and it has a static lifetime. Let's see. Okay, not bad. Alright, so then this execute function, method, is going to take in self, and then it's going to take in a closure where the closure is going to implement these trait bounds. The fn once, which is a closure that's can only be used once, send, the send trait, which allows it to be sent across threads, and a static lifetime. Okay, not bad. So let's see here, pool.execute cannot mutate. Okay, so it has to be mutable, obviously. Okay, so it looks like the compiler is happy now, even though of course the functionality is not correct. At least everything is happy. So now let's implement the thread pool. So the public struct thread pool, what are we gonna have here? As I said before, we're gonna have workers. Each worker is gonna basically listen for a job, and as soon as a job pops up, a job is just a connection. As soon as it sees a connection, aka a job, it's just gonna take the job from the queue, and then it's gonna grab one of the thread that's available, one of the 4 threads that's available, and just do the work in that thread immediately. And then once it finished, it will come back and it waits for the next job in the queue. This way it's very inefficient because we always only have 4 threads, and that's a predetermined number. And even if someone wants to attack the server and wants to send in a crazy amount of requests, we will just process it within those 4 threads. And so it's very safe for us and very efficient for the client as well. So the thread pool is going to have, let's see, workers. It's going to be the first variable, and it's going to be a vector of worker. Okay, and then it doesn't know what a worker is because we got to build that, right? So it's going to be struct worker. Do a bare minimum for now. Okay, so now let's see. Public struct thread pool workers. Okay, so the second thing it's going to have to carry with it in the thread pool is going to be workers, and the second thing is going to be the sender, because we're going to create a channel. The channel is what's going to allow us to send our job down the line into the next thread, so to speak. The channel is what's going to allow the thread pool to communicate with the workers. It's basically the queue, and each time we get a connection, we're going to have a job and we're going to send it down the channel, and that's where the worker is going to pick it up. It's like an assembly line. So we're going to create a channel first. Let sender receiver tuple equal multiple producer single consumer channel. Boom, just like that. Let's see, what is it? Go ahead and import that. Sender. Okay, so then this MPSC channel associated function is going to create a tuple. It's going to return a tuple, a sender, and a receiver. So the thread pool is going to have a sender, which is going to be of type MPSC sender, right? And the sender is going to carry a job. So the job doesn't exist, so we're going to build one right now. Job for now, just so we can satisfy the compiler. Okay, now let's see the sender thread pool. Okay, so before we finish the implementation of the thread pool being returned, we gotta create the workers. So let workers equal a vector, right, with capacity of size, which is 4, the size that we passed in. It could be 4, it could be 10, it could be 100, whatever, but in this example, it's going to be 4. All right, so we're going to have a workers. It's going to be a vector with capacity of size 4, and then let's see with that, for worker in from 0 to size. Yes, we're gonna loop through from 0 to 4, right? So basically 0, 1, 2, 3. We're gonna loop through that, and for each one of that, we're gonna we're gonna say ID. Yeah, because our worker is gonna have an ID. Each one of the workers is gonna carry an ID so that we know which worker it is accepting which job. So the struct worker is going to have an ID field of type usize, and also it's going to have a thread, right? A thread. Yeah, each worker is going to have a thread. So it's going to be a thread, and a thread is going to be, let's see, spawn. I just want to see what it returns. Okay, it's going to return a join handle. So that's what a thread returns. So that's what we're going to use. We're going to use a join handle of type T. In our case, we don't need a type. Yeah. So it's going to be a join handle. So it's going to be join handle. A thread is just going to have a, oh, because our closure doesn't return anything, so then we don't need to return a type, because the type T only applies if it happens to, if the closure inside that thread returns something of type T. But since our closure for this particular purpose doesn't return anything, it's going to be a unit type, which is blank, right? So it's going to be a join handle. I think I need to do that, right? Okay. All right. All right, so then let's see. For each one of those, we're gonna create a new worker. For ID, let worker equal worker new. Pass in the ID for that, and also the receiver. A receiver, right? Okay, I might have made a mistake here, but it's okay. So let's keep going. Okay, the compiler will help us. So let's go ahead and create a new associated function for worker. Let's see, fn new. Okay, we're gonna return a worker, obviously. Don't you hate when the cursor is just in the way? Like, man. All right, so it's gonna take in an ID, right? Which is of use size, and also a join handle, a thread, which is the join handle of the receiver. The receiver. Actually, I think the worker should keep a receiver instead, right? Let's see. Okay. New worker D E N. Let's see here. The worker should immediately be ID. I forgot if oh, let's think about this for a second. Okay, so I think what we're gonna do is, instead of passing in a, yeah, so we're gonna pass in a receiver, because with that receiver, the worker is gonna accept the receiver here, right? It's gonna be of type MPSC receiver. Let's see. So whenever we create a new worker, we're gonna go ahead and spawn a new thread, because if you think about it, a thread and a worker is kind of synonymous with each other, right? A worker is a thread is a worker. There's only 4 threads, so that there's only 4 workers. So we're gonna do left thread equal thread spawn. Yeah, and then we're gonna create a closure here. Now, what is that closure gonna do? We're gonna be listening on that receiver to try to listen for jobs, right? So as soon as a worker is initialized, as soon as he's born, pretty much, he's already listening for jobs down the receiver, down the channel, through the receiver. So what we're gonna do is we're gonna try to take out that job. Let job equal receiver. Oh, by the way, if you look, it doesn't let you pass in the receiver, and the reason being is because there's only one receiver, one sender, right? But yet you're trying to pass in one copy of that receiver to every single worker, and that's not going to work. So what we're going to need to do is put it inside of an arc, which is going to allow us to send. The arc is going to allow us to send it across threads, and we're just referencing it instead of it's a reference across threads. So we're able to send it across threads, and then also we're gonna wrap it inside of a mutex as well, because since we have 4 different workers trying to grab down at the receiver at one time, we don't want it to be a race condition, or so the mutex is gonna allow us to lock it as soon as one worker is trying to grab it. The mutex is gonna lock the entire thread. I mean the entire the receiver, so that the next worker, if he tries to grab it too, he can't. So only one worker can grab it at any given time. So we're gonna wrap it inside by saying, let's see, let receiver equal arc new, and we're gonna wrap it inside of a mutex, like that. How does that look? We need to import the arc and the mutex. Okay, so then now we can just say arc clone the receiver. Okay, so now the worker, we're gonna have to change the signature here. It's not gonna be this anymore. It's gonna be arc mutex receiver, and inside of it is a job, right? Okay. Yes. Okay. Let's see the receiver. Receiver. Unknown. Mismatch type. Receiver doesn't have anything in there right now. Worker, receive. Alright, let's do this for now. So the receiver is gonna have to lock and then unwrap in case there's an error, and then we're gonna take the receive method and also unwrap that in case there's an error on that method as well. So that's gonna give us the job if there is one available, and if there is one available, we're gonna go ahead and execute it. But first we're gonna print out a message so that worker ID number got assigned a job, executing. Okay, so it's gonna be that, and then we're gonna execute the job, and then after that, job finish, worker name finish job. Okay. All right. So the reason why we're getting this error, because for now the job, it's just a simple struct, but in all actuality it's actually it's a closure, right? So it's kind of like a function pointer in C. So we're going to implement that right now with a type alias. Job equal, we're going to wrap it in a box, smart pointer. It's going to be dynamic, and it's going to connect, it's going to carry all of these tree bounds right here. So fn1s plus send plus static lifetime, just like that. All right, let's see. Okay, much better. So thread spawn. Okay, so then worker can take that thread and return it. Okay, let's see. How does that look? What is this? Oh, we gotta move. Okay, we gotta move everything into the function, and then we're gonna want to loop this as well because the worker is gonna be constantly listening. So let's do this. Okay, so as soon as a worker is spawned, he's gonna be constantly listening at the receiver to see if there's a job being passed down the channel, and if there is, the receiver is gonna lock with the mutex so that no other worker can grab it. Only one can grab it at a time, and then it's gonna take out the job, and it's gonna execute that job, and then finish. And it's gonna continue doing that over and over again. All right, so then now that we have that, everything's looking good. We're going down here. Let worker equal worker new. So we gotta pass the job in here somehow, right? So thread pool, let's finish the thread pool first. Thread pool has a, it's gonna be workers and the sender. Okay, let's see, borrow, type, it has to have that. So receiver, job, text, receiver. What if I did that? No. Okay, well, let's keep going. I'm sure we'll figure it out. All right, so when we do execute this closure, how are we going to execute that? So basically, when we have a job down the line, what are we going to do with that job? We're going to wrap it, right? So job equal box new F, just like that. And then we're going to send it. Yeah, we're going to send it by going, taking the self, which is the thread pool. We're going to look for the sender, right? And then we're going to send this job, just like that. Probably going to need to, no need to unwrap, okay? Self, sender, okay? Job, okay? Worker, new receiver. Job, new thread pool. I don't know why there's this error here. I'm gonna look to see why there's an error right there. Sorry. Let's see. Okay, so I think it's just because I need to pass it. I just need to borrow it. Yeah. Yeah, as a reference instead of, yeah. So I thought even though, okay, so even though I cloned it, I still need to put a reference on it. All right. So let workers equal, oh. No. I'm just gonna push it instead of saving it as a variable. Workers.push. Oh, does that work? Workers.push, worker new, cannot mutate. Oh, okay. Okay. It looks like everything's working. Result must be used. Okay. I knew it. There has to be an unwrap on here. Looks like everything's working. Let's try that. Let's try to run this. Let's see what happens, okay? Alright. Cargo run. Okay, the compiler's happy. Let's see. We're gonna do the same experiment again. One is gonna go to sleep and one is gonna go to a regular, just a regular get request, okay? And as you can see, if I start this and then I start this, this should pop up first, not this. So this shouldn't have to wait for this. So 1, Well, that's not right. Oh, I think it's because it's been cached before. Let's try that again. Why is it doing that? Job unwrap. Oh, okay, I know why. Because wait, handle connection string. Why is it not sleeping for 5 seconds? Oh, wait. Has sleep as bytes. What is going on here? Why is it not sleeping? I mean, it's working, but I mean, this should be sleeping. Oh, there it is. Now it's sleeping. Okay. I'm gonna do 10 seconds. Why is it acting weird? Cargo run. Okay, let's do that again. Sleep. And then this one. Yep. So now this one works. This one got processed right away, and the sleep takes 10 seconds. That was not 10 seconds. That was really weird. What is going on here? Let me count. Hold on. 1. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that was 10 seconds. Okay, I'm so sorry. Okay. Okay, so as of now, the program is working. As you can see, I apologize for how sloppy the video is, and I just wanted to keep it real and honest. All of the errors, all of the looking around, trying to backtrack, trying to see, where I went wrong here. Like we're trying to follow the compiler. It's not pretty, it's not perfect, but I think it helps a lot to learn this way, instead of always relying on even AI, or anything, or just always relying on references, or just looking up notes. Sometimes just dig through it. You just gotta grit your teeth and just deal with it, and you come out on the other side. And I think this is a great way to learn. Just learn by failures, right? So now that we have a working program, let's make it better, because if we exit now, it doesn't exit gracefully. So what we're gonna do is we're gonna create a way so that we can send down the channel a terminate message. And when a worker gets a terminate message, I want that worker to go ahead and shut itself down, shut the thread down, and that way everything is gracefully done whenever the server exits. So in order to do that, the main is gonna stay the same. I don't think that we're gonna change anything from that. I could be wrong, but everything's gonna be in here. So we're gonna create a new enum called message, okay? And this is gonna be either one or two. Either it's gonna be a new job message, and it's gonna carry with it a job, or it's gonna be a terminate message, right? So we're gonna send the message instead of the job itself. So we're gonna wrap the job inside of a message, and it's either gonna have the message gonna be a new job which has a job inside, or it's gonna be a terminate message, and we're gonna shut down. So we're gonna change that. Let's see. Instead of sending a job, we're gonna send a message instead. Okay, the compiler's okay so far. Okay, so thread pool workers send a message. Sender message. Where did we get that? Anyways, okay. So then whenever we execute, instead of sending a job, we're gonna send a message. Let job equal. It's gonna be a message now. Box. New job, and gonna wrap that closure inside of that message, just like that. And then we're gonna send a message. Message use match type. Expected enum message. Oh, yeah. Sorry. Equal message, right? New job, and inside of that new job is gonna be a box. New F. Okay. So whenever we execute, we're gonna send a message down a channel. It's gonna be a new job message, and wrapped inside is gonna be the job, and we're gonna have to extract that. So now instead of job, it's gonna be message. So we're gonna pull out the message here. Yeah, we're gonna pull out the message, and let's see. If let what is that? Message. New job. Oh no, we're just gonna match it, right? Match message. Message. New job. For this arm here. Terminate. It's gonna be here. Okay. Match type. Expression as type. Message. Message equal. Ah, that's why. There it is. Okay. So now, if the message is, hey, you got a new job, we're gonna do everything that we did earlier right here. If the message is terminate, then we're gonna say terminate message received for worker ID. Okay, and then we're gonna break out of the loop. All right. So then we'll join the thread later on. Okay. So that should be okay. We're gonna do one. We're gonna implement the drop method for the thread pool. Yeah. Implement drop for thread pool, so that we have a customized behavior for when the thread pool drops, instead of just exiting without grace. So we're gonna do a drop method here, mutable self, and I think that's it, right? That's all that's required. Yeah, just drop mutable self. Okay, so then whenever it drops, what I wanted to do is to do self.sender.send terminate message terminate. Okay. Let's see. Job. So that's going to terminate the job, but then we need to terminate the thread as well. So for every worker, and what's the thread pool? For worker and workers. For worker and workers, we're going to terminate the thread, right? So it's going to be, how do we terminate this thread? So now it's saying that we cannot move out of self.workers because it's behind a mutable reference. It doesn't have a copy trait. So so what we're going to do instead is we're going to put an optional around the thread. So the thread can either be none or some. Option, yeah. So the thread is going to be either none or some. I think this is how you do an optional, if I'm not mistaken. No, I had it right the first time. Okay, so it's going to be a thread. It's going to be either none or some. Worker thread is going to be equal some thread. Like that. Okay. So what we're going to do instead is we're going to use a take. We're going to use a take method because the take method is going to take out the thread out of the optional and replace it with a none. Yeah, so self dot workers dot take. Sheesh. Now this part was confusing. So I might need to look at the reference real fast just to see how it's done. And okay, so then we got the okay, we don't need this because we don't use that variable, so we can just leave it like that and add a reference to that. Self.sender. This is a result, we gotta unwrap it. Okay, so that's for the thread. I mean, that's for the job. So in order to get rid of the threads, the 4 threads, we're gonna have to do for worker in mute self dot workers. Okay, shutting down worker. ID. Okay. So what we're gonna do now is we're gonna see if there's a thread. If the thread is already gone, we're not gonna do anything with it. But if there is, we're gonna use a take method in order to replace it with a none enum instead. So if let some thread equal worker dot thread dot take, just like that. So if the worker does have a thread that's still in there, that's still existing, that's a some variant, we're gonna go ahead and let them join it, so that we're gonna let them finish out whatever the drop method that we did earlier, this one here. We're gonna let him finish this out. If he doesn't have one, then we're not gonna worry about it. Then the method itself will replace it with a none in its place. Okay, so thread.join unwrap, and just like that. I think that's it. Yeah, I think that's it. So basically, whenever we exit a server, whenever the thread pool goes out of scope, instead of using the traditional drop method that it has because of the trait bound, we're gonna implement our own drop method. And so what it's gonna do is gonna loop through all the workers, right, 2 times. For the first loop, it's gonna send a terminate message down the channel. And so there's going to be 4 terminate messages. So all 4 workers are going to be able to grab that, right? And it's going to see that right here. And it's going to say, okay, we're going to terminate the worker now. So it's going to break out of the loop, because if we didn't do that, it would just keep looping forever, because it's constantly just waiting for a job. So when it does receive a terminate message, it finally gets to exit out the loop. So that's for the first step. The second step is for the threads. So what we're gonna do now is we're gonna loop over the workers again. So it's gonna be 4 times, so that when we're we're gonna look inside of each worker and we're gonna see, hey, do you still have a thread that's alive in there? And if it is, then we're gonna go ahead and call a join method on it, which allows it to do what it needs to do, which allows it to finish this right here, even if the main thread goes out of scope. If not, then we'll replace it with a none in its place. So we're gonna exit this program very gracefully. Everybody's gonna be cleared out and everything is gonna be correct. All right, so let's try that out, okay, to see if it works. We're gonna go back to main, and for the stream, we're only gonna take 2, okay? There you go. So we're gonna take the first 2 connections, and then after that, we're just gonna shut down. So let's try it. Okay. 1, 2, 3. Let's go back. 1, 2, 3. We're gonna do 4. Okay. Let's do 4. So let's see if it. 1, 2, 3. Nothing. Nothing. And if you go back, you can see it shut down very gracefully. Alright guys, hope you guys enjoyed that. That was my first time writing a project in Rust and doing it live, raw, unedited. Well, I did have to clip a few parts, but for the most part I tried my best to go in blind and just rely on my own understanding and using the compiler to help me, and just try my best to just, grind it out instead of relying on, notes or references or the book or Stack Overflow or AI or whatever. So I'm very proud of myself, and I apologize if it's sloppy. I apologize if it's choppy. I know it's a very long video, but I'm very proud of myself for it, and I hope that this helps you guys. And I really recommend this way of, learning, because this is probably the best way to learn a new language, especially one as complex and as as powerful as Rust. So with that being said, take care of yourself. Have a wonderful day. I'll see you next time.